We'll take a look here at quartiles in this section. Quartiles divide our distribution into four equal groups. Those four groups are separated by our quartiles, which are Q sub 1, Q sub 2, and Q sub 3. Q sub 1 is the same thing as the 25th percentile. Q sub 2 is the same thing as the 50th percentile, and Q sub 3 corresponds to the 75th percentile. In addition, Q sub 2 is also the median of the entire data set. So right here we have a series of steps to find our quartiles. First step, just like with our percentiles, we arrange the data in order from lowest to highest. We find the median. As I just mentioned, that median is also Q sub 2. That median then cuts our data set in half, all those groups that fall below Q sub 2 and all those values that fall above Q sub 2. So what we do is take the values that are below Q sub 2, find the median of that data set, that's our Q sub 1, and then we find the median of the data values that were above Q sub 2, that's our third quartile, or Q sub 3. A couple other terms associated with our quartiles. Interquartile range, the IQR, is simply the difference between Q sub 1 and Q sub 3. It's the middle 50% of the data, so Q sub 3 minus Q sub 1 is our interquartile range. That interquartile range is used to check for outliers. Outliers are extremely high or low data values when compared to the rest of the data values. To check for outliers, we multiply that IQR, the interquartile range, by 1.5. That's just a constant there. It's not a random number. It's 1.5. That's our definition, 1.5 times the interquartile range outside of our quartiles. But anyway, multiply our interquartile range, IQR, by 1.5. Add that value to Q sub 3. Subtract that value from Q sub 1. If there are any numbers that are above the value we found here or below the value we found here, those are called outliers and are considered to be very large or very small numbers when compared to the rest of the data values that are in that set. We'll do one more thing with the quartiles. We will do something called a box plot or a box and whisker plot, which we will illustrate in both of these examples. Our first one says find Q sub 1, Q sub 2, Q sub 3, the IQR, and check for outliers. We'll also construct the box plot or the box and whisker plot here just so we can see we've seen it a couple of times. We understand the idea. So first thing, we arrange these data values in order from smallest to largest. So I have a 5 and a 6, a 12 and a 13, a 15 and an 18, and a 22 and a 50. So there's our numbers in order from smallest to largest. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 numbers. To find the second quartiles, where we start, our second quartile is simply the median. In this case, our median is halfway between 13 and 15. So our median is 14. Our median is also Q sub 2. If we cover up these four terms here, these are the values that are below that. We find the median of that data set. That median would fall right in here. That median is 9. That is our first quartile. Then we have these values that are above our original median, 15, 18, 22, and 50. If we look in there, our median is 20. That is our Q sub 3. Okay, so there's how we find our quartiles. We find the median essentially of 3 different data sets. Once of the entire set, once of this subset of data, and once of this subset of data. So there's our quartiles. To find our interquartile range, we take Q sub 3 and subtract Q sub 1, which in this case is 20 minus 11. To check for outliers, we take that distance and multiply it by 1.5. That gets me 16.5. And our last step to check for outliers is to add that to Q sub 3. So Q sub 3 is 20 plus 16.5 equals 36.5. We also subtract that from Q sub 1, so 9 minus 16.5 equals negative 7.5. Any values outside of these two terms are considered outliers. So I'll start with a negative value. We don't have any negative values up here, so there's no values below negative 7.5. But above 36.5, we have 1, so 50 is an outlier. And that kind of makes sense. If you look at our data set, these numbers are all fairly closely grouped, and all of a sudden we jump from 22 all the way up to 50. Okay, so there is our outlier. and we added the instruction to construct a box plot. The box plot will occur on a number line, and we're going from 5 to 50, so I'm just going to go by 5s on our number line. And when we go to graph or make this box plot, we're going to graph essentially 5 items. We're going to graph the 3 quartiles, so 9 would be about here, 14 would be about here, and 20 would be here. Those 3 terms make up what's called the box part of our box plot or our box and whisker plot. They just show how those medians are grouped, whether they're spread out or close together. So it appears we have fairly equal spacing between our medians from here to here and from here to here. So those are the first 3 values we graph. The last values are the lowest term, which is 5. I connect that. There's the name whisker. And our other term is our highest term from our data set, which is 50. So I connect that with our whisker as well. So again, referred to as a box plot or a box and whisker plot. That's all there is to it right there. And again, it shows how that data is kind of spread out from our medians and also our highest and lowest term, because this whisker is quite a bit longer. Obviously 50 is a lot farther away than the rest of them. So one more time here, we have this information. Stockbroker recorded the number of clients she saw each day over an 11-day period. The data is shown below. Construct a box plot. So we'll do the whole thing. We'll do the Q sub 1, Q sub 2, Q sub 3, the IQR, and we'll also do outliers. Looks like our low is 23, 27, 29, 30, 31, like 33, 38, 40, 42, 43, and 51. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have all 11 values listed. Pretty much the same process. It looks a little bit different because of an odd number of terms. So 1, 2, 3, 4, 5 off of each end. 1, 2, 3, 4, 5 off of each end. Our median, or Q sub 2, is 33. We don't include 33 in the values below that. So for these 5 data values, my median is 29. That's Q sub 1. And for these 5 values, my median is 42. That is Q sub 3. So there's our 3 quartiles based on our information. Our interquartile range is simply Q sub 3 minus Q sub 1, or 42 minus 29, or 13. To check for outliers, we take that distance and multiply it by 1.5. That equals 19.5. We add that to Q sub 3, so 42 plus 19.5 is 61.5. We subtract it from Q sub 1. Q sub 1 is 29, minus 19.5 is 9.5. And if we look at our data set up here, there are no numbers that are above 61.5. Down here, there are no numbers below 61.5 or 9.5, so there are no outliers. And then to get to the final step, we want to make our box and whisker plot. So I'm going to make my number line across here. And we're going from 25 to 50. It's now 20 to 50. So we'll go by 5s again. We'll just spread them out a little bit farther this time. And much like with our last one, we're going to plot those 3 items. First of all, Q sub 1 is 29, Q sub 2 is 33, and Q sub 3 is 42. There's the box part of our box plot. So that rectangular box shows us that it looks like our upper set of data is a little bit more spread out because this box is longer. Our median's farther away from our original median. And these are pretty closely grouped here. Then we graph our smallest term, which is 23. Connect that with our line or our whisker. Our largest term is 51. We connect that with our line or our whisker, and there's our box plot or our box and whisker plot. And that is our work with quartiles, finding our 3 quartiles, finding our interquartile range, checking for outliers, and drawing the box and whisker plot.